Hey everyone, welcome back to Athletics. In this video, we're going to use a machine learning model to predict NBA match outcomes. If you haven't already, make sure to subscribe so you don't miss our weekly content, and check out AthlyticZ for course offerings. So this example is all about machine learning, and if you like this type of material, check out the case study included in Module 9 of the Python Machines course from Athletics. This case study is about using tree-based machine learning models to predict WNBA shot probability. Athletics courses are taught by industry experts with years of experience, and each course is packed with examples, quizzes, practice exercises, and case studies. Let's get into the video. So the first thing you'll want to do for this walkthrough is download the dataset we'll be using to train the model. We'll be using this NBA games dataset from Kaggle. The link is in the description of this video. All you need to do is download the dataset to your computer. Now we're going to get started writing our code. I'm going to start by importing pandas, and then I'm going to use pandas to load in my dataset. Mine is saved to my desktop, but you'll want to change this file path to wherever your data is stored on your computer. And then I'll just go ahead and print out the first 5 rows of my data set so that I can get a preview of what I'm working with. So I'll go ahead and run this code. And there's a quick summary of my data set. Okay, so before we dive into building our model, we need to clean up our data set. So this first line of code here is going to drop any missing values in the data. So if there is a missing value, we'll just drop that entire row. Next, we need to tell the model how to determine if a team won the match. So I defined a new variable here called win, which says that if the home team scores more points than the away team, then win equals true. If not, win equals false. Then I converted true and false into 1 and 0 so that the model can learn from it. The purpose of creating this new win variable is so that it can be our y variable or our response variable. In other words, it's the variable we are trying to predict. We're building a model to predict whether or not a team will win based on our x variables. The x variables need to be chosen very intentionally. These are the variables that are going to be used to train the model. So you'll want to choose fields that are correlated to y, but not fields that outright give away or leak y. For example, the home points and the away points would not be good choices for training a model on whether or not a team will win, because you know whether or not a team won based on the home points and the away points. You don't need a machine learning model to predict that outcome. Some better choices would be field goal percentage, rebounds, and assists. So those are the fields that I chose to be my x variables. All right, so moving on to splitting the data for training and testing. I'm going to start by importing a few more libraries from Scikit-learn. Next, I'm going to split the data into training data and testing data. And I'm going to use the function train-test-split. This function has 4 inputs or arguments. The first 2 arguments are x and y, or the explanatory variables and the response variable. Next is the test size, which I set to 20%, meaning we're going to do an 80-20 split. So 20% of our data will be used to test the model, and 80% will be used to train the model. You can adjust this ratio if you'd like, but 80-20 and 70-30 are the most common splits. The last argument is random state. Setting a random state ensures that you get the same split every time you run the code, which will make this experiment reproducible. So if you or someone else runs this code later on, you'll get the same split instead of reshuffling the data every time, which will ensure consistency in results. The number 42 is arbitrary. You could use any number you want. It's just common to use 42. Next, we are going to train the model. We're going to use Random Forest Classifier from Scikit-learn to build this machine learning model. The n estimator's argument is just how many decision trees to include in this random forest. So in this case, there will be 100 different decision trees in this random forest. The fit method is used to train the model on the given training data. Next, we're going to make predictions and check the accuracy of the model. I also printed out the prediction accuracy. This metric can be anywhere from 0 to 1. So an accuracy score closer to 1 means that the model is more accurate, while an accuracy score closer to 0 means that the model is less accurate. So let's run this code. All right, the accuracy score for this model is 79%, which is pretty good. That means that we've chosen good X variables that have a strong correlation to Y. If you get a prediction accuracy of 1, you should be suspicious. A lot of times that could mean that you chose X variables that explicitly give away your Y variable. For example, if we chose the home and away points as X variables, that would automatically give away our Y variable. We would know based on the home and away points whether or not the team won the match. So that defeats the entire point of creating a model. So we can actually visualize how well our model performed using something called a confusion matrix. This is super helpful for understanding where your model is getting things right and where it's making mistakes. So I'm going to use the confusion matrix display tool from Scikit-learn so that we don't have to manually build the plot matrix ourselves. I'm going to go ahead and print out this matrix so we can see the visual, and then I'll explain how to read it. All right, so on this matrix, there are 4 quadrants. On the axes, we have 0 and 1, and 0 and 1. So remember at the beginning of the video, we set our Y variable to win, and then we translated the win variable to 0 and 1. So we said if the match result is a win from the home team, it's a 1, and if not, then it's a 0. The predicted label is what the model predicted. So if the model predicted a win, then it would be a 1. If it predicted a loss, it would be a 0. The true label is the actual match outcome. So again, if the match outcome was a win, it would be a 1. If it was a loss, it would be a 0. So based on this matrix, we can quickly see how many samples we have of each combination. For example, this top left quadrant would be the number of times that the model predicted a loss and the actual outcome was a loss. On the top right, we have the number of times that the model predicted a win, but the actual outcome was a loss. On the bottom left, we have the number of times the model predicted a loss, but the actual outcome was a win. And on the bottom right, we have the number of times the model predicted a win, and the actual outcome was a win. So based on this confusion matrix, we can see that there are a high number of samples where the model correctly predicted a win. There are a moderate number of samples where the model correctly predicted a loss. And there are a low number of samples when the model either incorrectly predicted a win or incorrectly predicted a loss. All right, so we've built our model to determine whether or not a team will win based on field goal percentages, rebounds, and assists. Now it's time to try out our model. So I'm going to create a data frame, and I'm going to call it new game. And I'm going to fill it with data about field goal percentage, rebounds, and assists. Now I'm going to use the model we created to predict whether or not the team will win based on these X variables. I'm also going to print out the model's prediction. All right, so I'll go ahead and run this code. And based on these variables, the model predicts that the home team will win the match. I hope you enjoyed this video. There are so many use cases of machine learning in sports, and it's really interesting, so play around with creating your own model. Leave any questions in the comments, and check out AthlyticZ.com for data science training through the lens of sports. Thanks for watching.